How lovely to see you. Okay. Let's see. John. Edwin. Guys, you all keep moving around. It's getting very confusing. Testing my memory here. No Edwin, right? Abby. Rebecca. Ben. Aaron. Edgar. Dylan. Harriet. Ethan. Okay. All right. First thing, we're going to do, just close your notes. Oops. We'll do our first question. So tear this little piece of paper in half, put a 1 on one piece of it, and your name. And you can have a go at the question for 2 points now, and then at the end of the lecture you can have another go for 1 point. Okay? All right, so question is, when we look at muscle growth postnatally, do muscle cells grow by hyperplasia or hypertrophy? Is it the first one? Once postnatally, the muscle cells grow by predominantly by hyperplasia or by hypertrophy? Yes, I can. Actually. So which is the predominant form of growth in muscle cells postnatally? Alright, so give me that piece back. Save the other piece. Have another go at the end. Thank you. Yes. Thank you. Thank you. So, who remembers which one is which? Which is the type? I'm not going to give you the answer yet, just which term means which growth type.
Continued growth.
One of them is growth in number of cells, one of them is growth in size of cells.
Average number of cells.
Hypertrophy is sound.
Excellent. All right. Okay, so I think this is the slide that we had got to on Monday. We were looking at some issues around growth and adulthood. So remember we said that typically height is pretty stable until you're in your mid-late 40s, 50s and onwards, and then you start to shrink in height a little bit across time. Mostly due for compression of the cartilage discs between the spine bodies, but some people also have some problems with osteoporosis. But when we look at a weight curve, then what we see is that the majority of adults put on weight pretty consistently as they get older. All right? And that's not genetically driven, that's lifestyle driven. So I've got some control over that. It's just how am I going to take control? How am I going to fit in what needs to be done in order to not gain the weight? The more weight I put on, then the more risk I'm at for certain types of diseases. So we want to try to put this off. So, just to kind of pull that together, why we care about looking at adults and what's going on from a growth or development perspective. Because the adult population in rich countries has gone up dramatically. The number of adults in the US is much higher than it was. Somewhere around a quarter of the population in the next 15 years or so could be 65 and older. So there's quite a lot of developmental issues with that. How are we going to keep a quarter of the population healthy? If we don't know what happens to them developmentally, if we don't know what to expect from a motor skill perspective, then it's difficult to know what kinds of activities we should make available. How do we keep them safe? If we provide them an opportunity to move, then what do we need to do to make sure that they're safe while they're moving? Because it's no good to us if we encourage them to move and they all fall over and break their hip, right? That would be a large number of people requiring help. So, is movement decline inevitable? So a lot of people as they get older just kind of take the attitude that, well, I'm 75, I'm not supposed to be strong or be fit or be flexible or be healthy. I'm 75. That's just part of getting old, right? I don't walk as well, I don't run as well, I don't balance as well. Is that really true? If we don't research it, if we don't examine it, if we don't question it, we don't know. Does that have to happen? So far, the research says that it doesn't need to be as bad as many of us expect it to be. Right?
So this picture was taken, I think, I've had this picture a long time, but this gentleman was in his 70s when this picture was taken. Okay. This is what my dad looks like. He goes to the gym every day. He was 79 this Christmas. He's at the gym every day, lifting, riding the bike, on the elliptical machine every day. And he pretty much looks in good shape. My mom has always been pretty sedentary, doesn't make good choices for lifestyle, and so we see a very different picture. So far, the research indicates that if we stay active, so you guys have a big advantage, you're already active. Can you find a way to keep that going as you go out to work and you start families and you start a career? That's the tricky thing. But you've got a big step up over everybody else who's currently quite sedentary. If you can stay active, then we're seeing quite a lot of positive research that says movement decline can be delayed. Am I going to stop it altogether? No, right? I'm getting older. There's going to be some decline. But I don't have to become totally dependent, frail, unless there are other health issues. If I maintain a level of physical activity, then we can maintain pretty good quality of life and physical capabilities. I can play tennis, I can play golf, I can play pickup ball. Am I going to play a game of football? No. Right? Am I going to go and turn cartwheels and things? Probably not. Right? Gymnastics and football are not the best sports to take part in as a child or an adult if you want to have a lifestyle of activity, because they're not things you can do for your whole life. But I can be physically active at a very high level if I maintain that activity. And also, an interesting thing that we're starting to see in the research is that even people who are quite weak, quite unstable, quite frail, not very confident in their movement, if we put them into an appropriate movement program, that we can see quite a bit of improvement in that person's strength, in their balance, in their confidence, and we can see some reversal of the decline that they were showing physically. That's a great result to know, because now I can develop programs to help people who are not in very good shape. That's my job, because I'm the developmental person. Someone else's job to get them motivated to do the program, and that's a whole different kettle of fish. Okay. It's hard to get people. One of the things we want to do is really maintain bone density. That's key. Okay. Can I provide them every possible opportunity to maintain their quality of life, keep bone density? If they fall, I want to minimize the risk of them getting a big break, because that causes a lot of problems down the road for them. Okay. If I'm in my 70s and I know if I fall I'm likely to break my hip, and I know what the consequences of breaking my hip are, then I'm less likely to move. So when I look at my constraints triangle, everything interacts with the behaviors that we see. If I'm scared, I'm not going to move as much, or I'm not going to move as quickly. So if I can keep them strong so that they're not so worried about a break, then I'm less likely to see big declines in their choices of movement. Who has grandparents still alive? Are your grandparents active or are your grandparents relatively inactive?
Active.
Be active. Right. Watch the people in your families, because what you want is to encourage them to be as active as possible. Do they have dogs? Is it possible for them to have a dog or a cat? Cats aren't as good at keeping people active, although they are very good at keeping people engaged in mental tasks. Dogs have been shown to be a very good strategy to keep the older population active, because I've got to play with them, I've got to take them for a walk, I've got to at least take them out into the garden. So, on to chapter 5 then, and some of chapter 5 is just reviewing information we've already covered in chapter 4. So it feels like it's two lots of study work, but actually most of it all fits together, right? We've already said that many of the body systems are influenced by extrinsic factors. The skeleton less so. Fat cells, muscle cells, more so. My heart, more so. Right? If I drink soda every day, the insides of my arteries are pretty wrecked. If I drink water every day, they're going to be healthier. So there's external factors that can play a role in my structural constraints. Remember, structural constraints on our triangle are the things to do with the body, the build of the body, the size of the body, the house. Okay? So, when we're looking at these systems, we've got to have a decent idea what's the average pattern of change, so what's the typical picture, and what's the acceptable variation within that picture so that I can recognize someone who is atypical. Because we know that structural constraints are going to directly impact the movement that I see. So if I understand what's typical and atypical, I might have a better understanding of what I'm looking at. Why am I seeing this skill that looks a little bit weird? And I believe we mentioned rate limiters earlier in the semester, but rate limiters are the constraint, the system that lags behind when we're looking at younger children. So which is the slowest one that's developing that might be limiting the rate at which they can gain a new skill? When we look at the other end of the age range, then it's the system that breaks down, that deteriorates first, that impacts the maintenance of that skill. Right? So the rate limiter is the constraint that's affecting how well I can achieve a skill at a particular point. And we mentioned with the skeleton already, prenatally, remember it's growing from those little clumps, those dark clumps, the central, but in a long bone, once we've been born, it's going to grow from the epiphyseal plate, so it grows from the ends, okay? And so the growth from the ends makes it longer, but we also need it to get thicker. Okay, in the middle, if you look at a long bone, we have a bone. Got lots of bits of muscles over it. Not ideal, but this bit, right, I don't want to just grow from the ends and get longer. I need the shaft of the muscle to get fatter, to get thicker. Right?
so that it's stronger. And that's called appositional growth. We lay some cells around the outside. If we stress the bone enough, then we can make the bone nice and strong and nice and thick. So what causes the growth plate to close up and the long bone to stop growing in length? What did we say? What's the reason? Hormones. Good. All right. So during puberty, the sex hormones, once you've released enough of those and they're in your system at a high enough level, they're going to shut down that epiphyseal plate in the long bones, and you're going to stop growing tall. Your arms are going to stop growing long, your fingers and your toes are going to stop growing long. Doesn't mean I don't still get a little bit taller, because I still got growth in my trunk and in my spine, because they're not long bones. Okay. The epiphyseal plate is only on our long bones. So if I look at the population as a whole, typically we're going to stop growing in height around 18 or 19 from those long bones. Any growth from there is mostly in the trunk. Younger aging girls, so the plate is going to close and stop growing at a younger age in girls. Why? What happens? What's the difference? What's the difference? Why am I going to see the epiphyseal plate shut earlier in a girl at a younger age than in a boy? Sorry?
Because there is puberty.
Good, right? Simple. It's not a trick question, because girls go into puberty earlier, right? So what that means is, if you're working with this age group, remember that growth and maturation are not the same. So I have to understand that if I've got the same chronological age, if I'm working with 13-year-olds, I could have a 3-year span from a maturation point of view. Right? Some of them could almost be ready to stop growing. Some of them may not have even started puberty yet, and so have a lot more growth going on in their bones. So I have to take that into account when I'm looking at what kinds of activities am I asking. So bone is quite an interesting tissue, because we don't just grow it and that's it, it's done. It remodels all the time throughout our life. So we absorb old bone from the outsides of the bones, and we lay down some new cells around the outsides to keep the bone nice and strong. So that's pretty useful, because it means if I break a bone, it's not broken for the rest of my life. We have a mechanism to mend it. That's very helpful. But it also means that I have to make sure that I'm always laying down new bone. And there are a couple of factors then that I need to pay attention for that to be going on. What happens as we get older is that the amount of new bone that we lay down starts to slow down a little bit. And in some people, it won't keep up with how quickly they're absorbing old bone cells. That means then that the bone starts to get a little bit weaker. The density of the bone drops, how heavy the bone is. Right? Someone might stand on the scale and actually look like they lost weight because they've lost bone density. And it means that that bone is much more rigid, doesn't have any give in it, and it's more likely to snap, to break,
if I apply stress to it. Right? So if I fall or I twist, it's going to snap more easily. So the key here is, all right, if I know that this is a possibility, can I make sure I'm laying down enough bone? What do I have to do if I'm in control of moving, right? If it's me or my family, or I'm teaching at a rec center, or I'm running classes for retired people. What do I need to make sure they're doing so that we keep bones as healthy as possible?
Calcium.
We need to make sure they're eating some calcium. Right? So they're drinking milk, or they're drinking a milk substitute that has calcium added to it, or they're eating cheese, or they're making sure they have a yogurt every day. If they've got enough money, salmon is a good source of calcium. Right? It doesn't have to be dairy, but dairy is the obvious choice. Right? People often say, oh, well, I don't eat dairy because I'm lactose intolerant, but there isn't any lactose in yogurt or milk, yogurt or cheese. It's only in milk. Right? So lactose intolerant isn't a reason to not eat cheese or yogurt, because the process of making the cheese or the yogurt breaks the lactose down. You've got to make sure you're getting enough calcium, enough magnesium, enough phosphorus, right? All those nice minerals in your diet. If you can't get them in your diet, then there's some evidence that taking a supplement can be useful. You typically do not absorb calcium as well from a supplement as you do from food. So the best way to get it is through your food if you can. Because what we want to prevent is the bone becoming brittle. So we want to make sure there's lots of minerals available to keep it nice and strong. The other thing we have to do is encourage, I'm putting all this calcium into the system, but if I don't stress the bone, if I don't use the bone, there would be no reason to use the calcium to make new bone. We only adapt things if we stress them. So the other thing I have to do is make sure that I'm doing exercise that works my bones. So walking, weightlifting, running, playing basketball, not swimming and cycling. Okay? Swimming and cycling are very, very good activities for your heart. They are not good activities for your bones. So that doesn't mean don't do them, it means you have to have a range of activities, right? Don't only swim, because that's not going to help your bones. So, in adulthood, other than making sure that we're keeping the bone strong by replacing cells that are being reabsorbed, we don't see a lot of structure. My arms don't get longer or shorter. I don't get significantly taller or significantly shorter. My proportions don't change once my skeleton is set. Right? The structure does. I don't lose a piece of spine. Right? So the structure of the skeleton is pretty stable once it's matured. If we develop osteoporosis, the first level is osteopenia, means that you're losing some of these bone minerals and your bones are getting a bit weaker. Full-blown osteoporosis means your bone mineral level is pretty low and the bones are quite weak and brittle. So osteoporosis can lead to all kinds of problems. The rib cage can collapse. People often start to stoop because these bones are weak and so the muscles can't pull on them very hard to keep their posture upright, and you can see some reduction in height. The biggest problem is, what if I fall? Somewhere around 60% of the elderly people who fall and break a hip do not live for longer than a year. not because the fall kills them, but because the complications of hip replacements and being sedentary in a hospital and catching pneumonia or other things. They might not know the 60%, but they know that if they fall, chances are they may not survive for very long. So that makes people very, very wary. It's a big constraint when we're working with an older population. Right? But again, we know for sure that how much bone we lose is significantly influenced by my diet, by my physical activity levels, by my choices of physical activity. So if we look at an X-ray, these X-rays are in your book with a very nice explanation of what you're looking at on page 82. And so in a hospital, they would have a big book, an atlas that gives standards for X-rays for all kinds of ages. Okay? This one on the left happens to be the standard for a boy who's 48 months old or a girl who's 37 months old. So pretty young, right? You can see here the bones in the wrist are not calcified yet. The growth plate is not closed on the long bones. Fingers are still growing, right? Should not be doing a lot of weight-bearing work on their arms because the bones in the wrist are not formed yet, okay? Then if you look at this one on the right, then the one on the right is for a boy 156 months old or a girl 128 months old. So, quite a big difference. Now we've got the bones in the wrist calcified pretty well. We're starting to see a little bit of closure on some of the epiphyseal plates. Very different. X-rays are really useful when you're trying to look at the maturation because chronologically people can be the same age. But when I X-ray them, I can tell, is this person an early maturer or a late maturer, depending upon the maturation level of their skeleton. So they could be 12, but when I X-ray them, their bones look like a 9-year-old. Well, that means that they're going to be a late maturer. They're going to go into puberty later. They're going to be laying down bone for a lot longer. I could measure them at 12, X-ray them, and see the skeleton of a 14-year-old. Well, then that person was an early maturer. Okay. So X-rays are very useful at determining maturation. They've got some other problems associated with them, so you don't want them unless you have to have them. But sometimes they do need to use them if they're seeing some developmental delay to try to work out what the real maturation level is. Okay. All right. Questions on skeleton? Remember all the time, right? Try not. I think sometimes this part of the development stuff gets a little abstract because you're sitting there thinking, well, this isn't meant to be an A&P class. But remember our triangle. If I don't understand the constraints that are involved in the individual that I'm working with, then I can't understand the behavior that I'm seeing that person produce. Okay? All right, muscles then. So, postnatally, after birth, predominantly muscles grow by hypertrophy. Okay? So they get bigger in size. We don't lay down very much new muscle after birth. That means that all your muscle cells are in place when you're born, mostly. Not 100%, but most of your muscle cells are in place. Most of the growth that you see in muscles is due to the cells that are already there getting bigger. So remember, it's attached to the bone. So when the bone grows, tugs on the muscle, and then the muscle has to grow to keep up with the bone. So the skeleton grows first, tugs on the insertion, stimulates the muscle cell to grow, put an extra block in. What I don't see is new muscle cells. Right? The ones that are there get bigger, they get longer, they get fatter, we put more protein into them. Does that make sense? Right? So if you've got a kid who is growing very, very quickly, chances are they're going to indicate some weakness that you may not have expected, or some lack of coordination that you may not have expected, as the muscles take a while to catch up. Even in a girl, it's just not as dramatic in girls because the growth in the skeleton is not as dramatic in girls. Even in our kids on the playground, right? They're all still growing. Some of them have done a big growth spurt over Christmas, we're seeing. So it'll be interesting to see what impact that has when we're out on the playground in a few weeks. So muscle growth, if I was just looking at muscles, I would also see that similar S-curve. Okay? Lots of growth when they're younger, little plod along growth, big growth during puberty, and then what happens as an adult. Again, muscle tissue is very influenced by external factors, by the environment. What do I feed it? How do I train it? Is it growing? Am I losing it? Okay. Anybody know what a sarcomere is? Who's had AMP yet? The sarcomere, what do we have? So when you look at a muscle cell, the cell's made up of these little blocks. Right? And the block is a sarcomere. So what happens when we tug on the tendon, because the bone is growing, it encourages the muscle to lay down some extra blocks and get longer.
So what happens to a person what happens to bodybuilders when they're lifting? Does it just shrink?
It takes time,
But that's
but yeah, eventually it will shrink if they don't continue training. But muscle's quite interesting because having put the size on, it gets weak very quickly. You lose the strength that it's able to generate, but you don't lose the size very quickly. It takes quite a lot of time for the muscle to break down and for you to actually lose size. So if you do a lot of aerobics, you can help that a little bit. But it can be a little bit disconcerting because you're like, oh yeah, I'm still kind of big and strong, and when you go to pick something up, it feels like it weighs a ton, and yet your clothes aren't getting baggy yet. Right? So yeah, don't go out and buy yourself a new wardrobe the day you stop competing, because it'll be a year or two before you start shrinking enough to warrant spending money on a new wardrobe. And muscle responds very rapidly to sex hormones, particularly testosterone. So again, in puberty, not only do we see changes in the shape of the skeleton. We also see changes in the muscle tissue because boys are going to lay down a lot more muscle tissue than girls, and therefore they're able to be stronger. That's an important point. They're not stronger because their muscle is better than girls. Their muscle is no different than the muscles girls have. They just have more of it, and therefore they're able to generate more force. So if you have a little boy and a big muscular girl, chances are she could be significantly stronger than the boy. And you might get that in the same class because the boys are late mature and the girls are early mature. All right, so today is Wednesday. We're going to do muscles. We are going to look at adipose tissue, fat tissue, because that's quite interesting. We will not have time in class to cover the endocrine system. We can't do a third class on chapter 5. So in chapter 5, I'm not going to be covering the endocrine system. Right? So just make sure that when you're looking at that chapter, you don't panic because there's a load of stuff there that you've never heard of. All right, so little bits of paper.